So the first part would be using G1000 and GTN 650 Xi features, and it would be fuel and time management with G1000 and GTN 650, descent planning with G1000, true airspeed and wind calculations with GTN 650 and GTN 650 demo mode. Let's start with the fuel planning. As much as we want to fly with full tanks all the time, it's not always possible due to weight and balance, but nevertheless, we want to stay airborne for as long as we could. And this page will help us to plan our fuel. So it's in auxiliary. It's the first sub-page of auxiliary page, and it has several blocks. And also it has several modes. First is auto or manual, and then flight plan or waypoints. In auto mode, G1000 will use all the data it can pull from all the sensors, such as airspeed, altitude, fuel flow, and use them for continuous calculations in real time. Manual mode is when you can change any field manually, which might be useful if you're planning on the ground or you just want to get an estimate for a different ground speed or different fuel flow. And flight plan is mostly what we would use, but if you want to just do calculations between 2 points, or maybe one of the points is not even on the flight plan, then waypoint mode will be the best. And so the first block you will have, well, if it's in flight plan mode, your flight plan, REM means remaining, so it will calculate it for all the legs from present position to whatever the last point is. Departure time is not populated because it's always the departure time. It's real time from the present. Ground speed, self-explanatory, fuel flow, and fuel on board. Keep in mind that fuel on board is the fuel that you enter in G1000 in the beginning of the flight. That's the only number it will use. It cannot read the fuel gauges. So make sure that you enter the correct amount of fuel on board in the beginning of the flight. Then trip statistics, distance to go, ETA, time of arrival, en route altitude, en route safe altitude, sunrise and sunset times. And fuel stats, that's the reason we're talking about this page. So first is efficiency in miles per gallon, nautical miles per gallon. You want this number to be the highest if you're getting low on fuel. But in general, any change in your airspeed or power setting will show you if you're more efficient or less efficient. Total endurance is the time left until the tanks are dry, or more precisely until this number is 0. And remaining fuel is the fuel you will have in your tanks after you have reached the last point. So if the last point of your flight plan is your destination airport, you should be aiming for around 12.5 gallons, which is roughly 1 hour at cruise in our 182s, or remaining endurance will actually tell you how much time you will have left after reaching the final point, so that you want to be 1 hour, because CAP regulations require 1 hour fuel at cruise speed after the landing. Then fuel required and total endurance, how far you can go with no reserve. And of course, if you add this number to this number, you should get fuel on board. And then the last 2 blocks are pretty much all this stuff you already can see on PFD, except the density altitude, which, as far as I know, is unique for that page. Now, if you add, let's say, an approach to your flight plan, then remaining would mean that it will calculate everything up to the missed approach fix. And you can see that after I added an approach to FTL, now the time to go or time of arrival increased and fuel required also increased. However, you can use the cursor to change your lags, and you can just calculate it to a specific point, for example, to the airport, or if you're going to fly an approach, you can calculate it only to your airport, which would be your pretty much missed approach point. Also, you can see pretty much, well, you can see pretty much all the information about your fuel on your flight plan page. So you can see how many gallons you will have left and the time you can stay in the air after you have reached this waypoint. However, you can only see those data if you are in a wide view of your flight plan. And to switch views, you would use soft key view and then select wide. Also, if you zoom out enough, you can see the rings. And the outer ring, the solid ring, is your basic endurance, how far you can go at the current ground speed and fuel flow. And keep in mind that all those calculations assume that nothing will change, that the wind will change, your ground speed will not change, you will not change your power, which will change your fuel flow. So that's the outer ring. The inside that ring is where you will reach your reserve, and that is the number. This number is the time until you will reach your reserve, and you can change your reserve in your map setup. So in this case, it's set to 45 minutes, so it would be 21 minutes until you reach your 45-minute reserve. For cap operations, it should be 1 hour, and that's how it looks on a real G1000. So it's set to 1 hour. So in 1 hour, 52 minutes, this airplane will reach its 1 hour reserve, and the solid line is the absolute maximum it can go at current ground speed and fuel flow. You can also do fuel planning in GTN 650. If you go to utilities, you will see fuel planning page, and it's in a way it's the same thing. However, keep in mind that most, if not all, our 172s don't really have fuel flow gauge integrated with the Avionics, so the data would be as good as the fuel flow you enter. So be more careful using that for planning because it's less precise. But in general, when you click compute data, you will get this page. You can use next and previous to basically either see the everything cumulative or specific lags. The next thing I'm going to talk about is descent planning, and I personally think that descent planning is very often overlooked during the private pilot training. And it becomes a problem when people start flying high performance airplanes. So you can imagine if you're flying a Cirrus at 20,000 feet at 160 knots, you cannot start your descent when you see the airport. It would be too late. And of course, you should know how to plan for your descent. And there are two ways. One is using the descent rate, another one using descent angle or flight path angle. But G1000 can help you with that. And all you need to do is to enter altitude for the point you're interested in. And if it's an airport, then you can actually use AGL, and then it would be converted to MSL. So you will always see MSL, but you will have an option to use, like, for example, if you want to be in the pattern, you just enter 1000 AGL, and it will set you for the pattern altitude. And then you would use PNAV profile to either select the vertical speed or flight path angle. And when you will reach your descent glide slope, basically, vertical speed required and vertical deviation would be populated. And that's the number until the top of descent. If you click VNVD, which is VNav direct, you will start your descent. Well, I wouldn't say immediately, but it will give you 1 minute to get ready, and then it will start the descent. Also, you can see that on your map, you will see a top of descent point. And here I use the cursor to measure the distance from top of descent to my destination. And if you will do the math, it should be 11 miles at with a 3-degree glide slope. And you can see that it's indeed 11 nautical miles.
Vasily, quick question. Can you go back to the previous slide? What was the VNAV-D button?
It will, so if you just do regular descent profile, you will set your vertical speed or descent angle. And when you will reach that glide slope, the descent will start. If you just don't want to do it at a specific glide path or specific descent rate, but you want to start it immediately, for example, ATC tells you start your descent now, then you will click VNAV-D, and it will select the vertical speed and the flight path angle for you, so you can stay on that descent profile at your pretty much present position.
So basically from your current position. Got it. Thank you. Sorry, I missed that point. Thank you.
Yeah. All right. And that's how your PFD will look when you approach your descent profile. So you will have 2 carrots. One will act pretty much like glide slope on an ILS approach, and another one will give you the vertical speed to fly. As I said, you can see it here, but you can also see it in real time on your PFD. And also notice that now, so that was calculated for the airplane at 5,000 feet. And then I descended to 4,000 feet. And you can see that now the descent should start later because I'm lower, and actually it should be 8 miles out. And you can see that 9.4 miles, and it's still, I'm still below the glide slope, meaning that all those calculations are done in real time. If you climb or descend, it will recalculate everything. So after you have selected that, that's it. You just keep flying the airplane. You don't have to worry about it anymore. And also, if you have an autopilot, which I think only one airplane in the wing has it, I mean Garmin autopilot, it will fly the descent in VNAV mode. If it's just a Cap 140, then you will either have to fly it by hand or to select the proper vertical speed on Cap 140 to fly it on autopilot. And also at the top, you will see the target altitude. And also if you're flying it on autopilot in VNAV mode with the Garmin autopilot, the autopilot will not descend below this number. So it's basically would be your altitude bug or your target altitude, whatever is higher. So if you want to descend to that altitude, you'll have to set your bug to 1500. All right, moving on to GTN 650. You can also use it to calculate density, altitude, true airspeed, and wind. Again, in utilities, you have V-out, TAS, winds. And if you click use sensor data, it will use all the sensor data that are available. Again, for most 172s, we have not that many data can be supplied to G1000, so you have to pretty much enter them manually. But after you have done it, you click compute data, and you can see your density, altitude, your true airspeed, wind direction, wind speed, and head or tailwind component, which is pretty nice. And to conclude that part, remember that all GTN 650s or 625s, pretty much all this 600 generation of Garmin GPSs, they have demo mode. So if you push and hold direct to button and then while holding it, power up the avionics. So you should press it when your avionics is off, and then you press it, hold it, turn on the avionics, and it will boot up in demo mode. So in demo mode, you can put your airplane on in any position on the map. You can also change its airspeed or altitude and see how it flies, either the route or the heading you told it to fly. And also it will be supplying the data to your GI-275. So whatever indication you would see if you were flying this route, you will see it on GI-275. And also don't forget that there are free Garmin simulators for PC and for iPad. And you can also buy a G1000 simulator from the third